before you do the final tightening. That does two things. One, it looks nice, and two, it keeps the bracket from touching the hot terminal, which can cause a short. If you're not careful, that's what the bracket tends naturally to tighten up and touch the terminal, so we don't want that to happen. Now, we get out our beautifully powder painted oil breather can, and there's one special attachment here, rubber grommet that goes over it. It's a little snug, almost like the distributor drive, but it's not. You put it in like so, and we get out the special bolts that are used to attach the oil breather can to the generator stand. And we need 4 washers, 1, 2, 3, 4, and 2 6mm nuts, and sometimes 2 wrenches. Small wrenches, the smaller the better to get in there. We use the best washer on the outside, 1 washer under the head. That fits in that way. The other washer under the nut. Like that. Put a washer on the other bolt that goes on the inside. Here you can use the lesser of the 2 bolts as far as goodness is concerned. Goes with another washer and nut on the other side. Sometimes to get enough travel you have to tighten down this one side a bit, force the gasket to compress so that the other side can be screwed on. Okay, now the fun begins. It's hard to hold, so you have to usually put a wrench on it. Then use a very short 10mm across the flat wrench box end to tighten it down. Try not to scratch the fan shroud or the cylinder shroud when you do this. Use your hand as a guide to keep it from doing that. And tighten it down until it's pretty snug. Then go to the rearmost one and tighten it. It's really a pain to get to this, but you only have to do it once in every 100,000 miles, hopefully. There we go, now we're tightening down nicely. 3, 2, 1, ignition. Okay, likewise, tighten this one down. Voila! Oil breather can is now attached, just like it should be. While we're here, we may as well put the fan belt on. And we have new generator halves. They come with a lovely little part number mark right here. And it's hard to remove, incredibly difficult to remove, so you're better off not removing it, and the fan belt will remove it for you. Put the front bracket is the one with the notches for taking everything off. Don't forget that. You put that on, and you get at least 10 of the washers. And you put 7. I found 7 to be the lucky number here. 7 come 11, but it's 7. On in the middle between the pulley halves with a new fan belt. That's the proper number of washers for 5, come on, 6, 7. And then I prefer Porsche fan belts to say Porsche on them. Of course, I'm afraid you won't be able to find these anymore, but the Maestro does have them for engines he does build. Even Stoddard no longer does supply the Porsche ones. They used to a while ago, but they have just Continental. Continental works fine. They're a good belt. They're 825 millimeters long by 9.5 millimeters wide, and that's the number you should remember. This one with Porsche, I always put the Porsche so you can read it. That's the way they want to go anyhow. And you get out your CAD-plated rear pulley half. Boy, look at that baby shine. Isn't that neat? Stick that baby on there. Put on 3 more shims at least. You want to have at least a total of 10. If you're too few shims, the nut won't tighten things down well enough. And if it doesn't tighten things down well enough, it'll rip out the center section of the inner hub. Then good luck trying to get things off, especially when you're broken down out in the boonies. So now, we get our 36 millimeter wrench out. The one we used to torque down the flywheel nut was the last time we used it. And we can just torque around, like so. And things will tighten down automatically, and that's not too bad, about a ½ inch of play in the middle. We can put our wrench, our screwdriver, in place here against the nut. Now we don't over tighten this thing, which we really can do with a 36 millimeter socket. Just want to tighten it down to where we can get it off again. Check it, not bad, pretty good. We'll probably have to readjust it in 100 miles or so. But in general, the belt should slip a little bit on compression, but not terribly much. That's about right. 7 washers in between is a good number. Okay, boy, it's looking like a Porsche engine now, isn't it, huh? Next step, just next thing we may do before we put the manifold adapter plates on, is to put on the top linkage crossbar and the spring plate. This takes a spring plate type, all newly CAD plated. To do that, we CAD plate also the other end here, the ball. So we put the ball on first. I like to use nice new washers on things and nuts because they look nice that way. And usually we can do most of the adjustment on the other side. But 1 washer on this side, 1 washer on the other side. Put it in like so. This is hard to hold, this particular one. You have to hold it with a pair of pliers. I know it sounds gross, but that's the way it is. Tighten it down. But you don't have to tighten it down, you have to really lean on it. It's not too bad. We take our cross linkage, top cross linkage bar here, or top linkage crossbar, depending on how you want to call it. Put some lovely wheel bearing grease, heavy duty, high temperature stuff, the best stuff you can get. Wipe off the excess. It's messy, black. You can use Bosch high temperature grease too, Bosch distributor grease. But I found actually the wheel bearing grease seems to work a little better. The bracket that operates the bar is on the left hand side as you're facing the engine. You stick that in, put that in below the plate, the bracket that holds the fuel line. You get out the spring plate that goes on this side, and 3 6 millimeter bolts. These are not critical bolts, so they don't have to be matched names, but of course I like to use them. 3 washers. Get the spring plate in, put the washers on. Be careful you don't drop anything down. Inside the intake manifold now, it's very close here. Screw in 3 bolts. Get them all in loosely, then you can use either the 10 millimeter wrench or 10 millimeter socket on the bolts. There we go, socket's right here, we use it. Now to adjust the spring plate tension, we can do it by adjusting the number of washers on either side of the ball, or we can put spacers underneath these bolts between the spring plate and the fan shroud. Let's see how this works. If we're really lucky, we won't have to do anything. But luck hardly ever comes to those who don't work for it. That's not too bad. It's pretty smooth. Wiggle it back and forth. It's got a little bit of friction there, but not much. That's not too bad. In fact, I think we'll go with that. Alright, now we're going to put the clutch and pressure plate on. This is the mark made by the machinist to balance the pressure plate and flywheel. And we have here the pressure plate, we have here the clutch disc, and we have here the tool necessary to adjust everything, which is nothing more than the Porsche main shaft that's been cut off. It's the ideal tool. You can buy a cheap wooden one for about $3, $4, $5 from a foreign auto parts store, but these you can use either from a Porsche transmission, which this is, with a bent main shaft was no good, or a VW transmission. Okay, so we put the clutch disc in. We've cleaned off the flywheel here with Comet and steel wool. Got it nice and clean. Find the corresponding mark on the pressure plate. Put that on like so. Then the dowel pins will all align very nicely. Put the part of the main shaft in place into the flywheel nut. I like to use the Allen head bolts and new washers. And we attach the Allen head bolts loosely. There's 6 of them. Put all 6 in, then tighten them down one turn at a time while we check to make sure that there's no binding anywhere in the main shaft piece, the clutch alignment tool as it were. If there is binding, we have to loosen the Allen head bolts and make sure that we align the clutch disc to be certain that when we put the engine in, the the main shaft of the transmission in our car will align properly with the splines of the clutch disc. If we don't do that, just randomly put the pressure plate and clutch disc together, we will find, much to our chagrin, that we can't get the engine to go into the car because we can't get the main shaft to align with the splines of the clutch disc. So here we go. You need a 6mm Allen wrench, and what you should do is just tighten things down till they're snug. You can get a 6mm Allen wrench attachment to your socket too, but it's hard to get everything in place here. Now you should do it across alternately, that is across 180 degrees of the flywheel pressure plate, but right now we'll just tighten things down. Now see, the alignment tool is tight, so we have to loosen things up a bit. We were too hasty until we can once again move the alignment tool. Tap things around, tighten down the bolts we have not yet tightened down. Make sure the adjustment tool will adjust and move in and out. This takes a bit of time, but a bit of time well spent, because the clutch is very important. To do any work on the clutch, you have to remove the engine and then put it back in again. And to remove the engine is not much fun. I like to put these things in once and not have to play around with them. So if you do everything beforehand right, you won't have to play around with them, hopefully. So once you get the nut snug, at that point you can torque things down in one turn at a time, alternately. Like that. Keep going around, one turn at a time. And about every turn or so of the bolt, stop and check the alignment tool. Make sure it moves back and forth easily. If it doesn't move back and forth, you have no choice but to stop, find the reason why, which usually means loosening all the bolts again and starting over. After a while, when everything is tight or is starting to snug down, then the clutch disc can't move anymore and you'll be all right. But still, make sure that you tighten things down, tighten the bolts down one turn at a time maximum. You can watch the fingers of the pressure plate And if one side gets too far in, they will slowly come inwards towards the flywheel, that tighten the opposite side or loosen the side that's in too far, and you'll be okay. After we get everything tight, we'll take a hammer and hit the end of the wrench here as like an impulse wrench would, impulse engines, and that will make sure everything is nice and tight. It won't come loose when you don't want it to. So far so good. Balancing is the most important thing you can do to your engine for long life. I balanced every engine, whether it be a Porsche, a Volkswagen, or a Chevrolet V8. When you balance things that can be balanced perfectly, you should. It makes them run a lot better and last a lot longer. And you can tell everybody at Maestro said that. Now at some point here, the flywheel is going to start to turn like that, which is good because then you can bring everything up to where you are and then make sure it's tight. When you do that, it's kind of like bringing the bolts to you like that, and that's indicative of the fact that everything is now getting very tight. You should always, when you're done, have everything within a half a turn of being tight. You'll occasionally drop the wrench, it happens. Check the clutch shaft, or the main shaft piece, make sure with your adjustment tool, clutch alignment tool. Okay, we now have all 6 pretty tight. You can use a 3-pound sledge, but you don't have to. Just use a regular hammer, whack it a few times, drop the wrench again. This always happens. These things are really a pain. Bring everything around so you can get to it. Give it a few more taps. You can use Loctite on these bolts too, it doesn't hurt anything. I'm a believer in Loctite for certain applications. I think it does a good job at preventing bolts and nuts from loosening up. And now, it's 4, we got 2 more to go. We're just about done. Well, we got this side of the engine, this is actually the front side of the engine, towards you. We should put on the thermostat, and we have everything here ready for that. It's all done. Don't forget to remove the clutch pilot tool. Here's a thermostat. It requires a special, short, 8 millimeter bolt, 14 millimeter across the flat, kind of like the cam plug. Put the thermostat in, got a little cord, 2 cords cut out of it, and you put the alignment, the adjustment bolt, one that ties it down, 14 millimeters across the flat, and tighten it down. Now we're pretty much done here for the time being. We still have the fuel line and linkage to put on. We'll do that a bit later. So I'll turn the engine around, and now we found the piece we need to do the distributor. And the piece we need is this piece here. It's usually found in the lower end gasket set, though some of the gasket sets nowadays don't have it. It's nothing more than O-ring seal. And you pry it over the distributor shaft, put it right there. Helps to lubricate it with a secret sauce, because a new one is sometimes hard to put in. Lubricate the area where the distributor goes with the secret sauce, doesn't hurt. It also helps now to crank the engine around to top dead center on number 1 cylinder, which we can tell from the cord, which if we install the distributor drive correctly should be parallel to the split of the, where the main case attaches to the, where the third piece attached to the main case halves. then the OT mark should be aligned with the notch in the case. And lo and behold, it is. Now, there's a notch on the body of the 050, like there is on most all Bosch distributors. There it is. That notch, the rotor should point to at top dead center on number 1 cylinder. Now, the 050 is kind of unique in that when it does that, the rotor is not pointing at about 4 o'clock, but more like 7 o'clock. So let's put it in, rotate it around. As I was saying, it sometimes helps to have a little bit of persuasion in the form of a rubber hammer, like that. Rotate around till it snaps in place, and when you put the rotor on, you'll find it's pointing at about 7 o'clock. Now that's top dead center. There's a notch. You get things vertically aligned. At that point, if you pull the rotor, the point's just barely beginning to open. And lo and behold, they are. Get the snaps out of the way. We will adjust the timing a little later with a volt ohm meter. Show you how that's done. Time being, we'll put the rotor back in place. Get it aligned so that this notch in the rotor is directly above the notch in the body of the distributor. And we will then tighten down the bolt that holds the distributor in place. For the time being. That's a pretty good rudimentary timing. It should be very close by the time we get done with this. We then attach the wire to the coil on the right hand side of the coil. You can put it either way. I personally like to have it that way. Looks nicer. And we put the distributor cap on. I like to take this ID part number tab off of this thing. WD-40 works well to take off the sludge. There's a notch in the body and a particular notch here in the cap, and they align, snap in, put the snaps in. This is number 1 cylinder. Don't forget that. We then get out a wire set, which in this case can be a VW wire set. Open it up. Find the coil wire, which magically appeared in front of us. It's the first thing to put in. It gives you the feeling of accomplishment. You're doing something right. You can't screw up the coil wire. It's the shortest one, and it goes from the coil to the center of the distributor. Take the other wires, unscrew the Volkswagen ends that are here. You might want to save the skirt. That can be saved. The rest of it can be tossed. It can be unscrewed by hand. Throw them away, but save the skirt. You might want to save the ends too, but if you have more than one wire set, you don't need to save the ends. Unscrew them all. Then, get all 4 of them, 4 ends together, and you'll find you got 2 the same length and 2 there about the same length. That makes life easy. You take 1 long and 1 short. You take the O-ring seals, which are actually tied together doohickeys, and you put them over the 2 wires. Helps to lubricate them a little bit. Now, here comes the trick. The long wire is going to go to number 1 cylinder. So you should arrange it like so the long wire is on the bottom. You then get out the Stoddard. They're the only guys that make these things. They're little rubber tunnels, as it were. Like this. These are the tie downs. The little nipple on the end, which I'll show you in a second, goes into the sheet metal here. Okay, put a little secret sauce on it. That allows easily the wires to go through. In fact, it's so nice and slippery it allows your hand to fling it across the room. Get the other one out. Have your assistant go find that one. Push the wire. A little more secret sauce required here. Push the wire through. There we go. Bring it down. Put the other wire through it. Get another one of the tied together doohickeys, just an O-ring, but the right diameter to work. Other O-rings are not the right diameter. And if they're not the right diameter, the wire won't look nice. Get out the original Porsche ends. I like using Porsche ends. Stoddard has them. Other people may too. But Stoddard's the main source. They have a spike in the center, a screwed spike. And they screw into the wire, just like the VWs did. Screw them down till they're tight. Get the other one out. Screw it down. Step over to the right-hand side of the engine. Stick the number 1 plug wire on the spark plug that we've nicely installed. Stick the number 2 plug wire on. Now remember, the number 1 is the lower one here. So keep that in between your thumb and forefinger as you run it through. That's number 1. And on 050, number 1 is over here, if you remember. Firing order is 1, 4, 3, 2. Cylinder is 1, 4, 3, 2. Here's number 2. So we take number 2 plug wire, put it in there. Put the cap on. We got those 2 wires attached. Repeat the process. Now on this side, the number 3 cylinder should be underneath. So we arrange that underneath. Take the tie together doohickey, put it over the one wire, over the other one. Take the nice lubricated with special sauce tie down doohickey, put it in. This time it goes in, not across the room. Get the other wire through. Push, struggle, push. Nothing is worthwhile unless it's obtained after a struggle. Take the other tie together doohickey, the O-ring, put it over both wires. Get out the remaining 2 original Porsche wire ends. I like using them. They're a lot easier. They have a little knob on the end. They're a lot easier to pull off. When you want to get the wire off, you pull on the knob, not the wire. The VWs are extremely difficult to get off. They're tapered, they have no knob. And if they get wet with oil or anything, good luck getting them off. Okay, firing order 1, 4, 3 is there. 3 is going to be here. Put 3 on. Trace the wire, it's the lower one. 1, 4, 3, it goes there. 3 goes in like that. Put the cap on. The only one remaining is 4. It goes in there and here. Now, put the cap on. Arrange the wires. You can move them back and forth through the tie together doohickey. You can move them back and forth through the tie down doohickey. Get them to where they're happily arranged, about like that. Put some secret sauce on the nipple. I bet you like doing that. Put some secret sauce on the hole. Get out your special wire installer. Arrange things. Get it right there. And here's where we separate the men from the boys. Give it a whack. Doesn't go in. Give it a few more whacks. It goes in. That's what she said. Come over to the other side. Special sauce on the hole. Special sauce on the nipple. Arrange things. This is a little tight here. The wires, the VW wires are not exactly the right length. But they do function, though number 2 is somewhat on the tight side. Oh, so hold everything. Don't hit your finger when you do this, but you have to come somewhat close. Get things arranged. Bring the other tie together like you can see it here. Voila. We install the 050 distributor, original plug wires, tie together doohickeys, tie down doohickeys. Okay, now our next step is we're going to be using Weber carburetors. We have a Weber carburetor adapto plate. This is the better kind of adapto plate, and I'll show you why. When you open it, you'll find the adapto plate part of the kit is bored here. They recently added that improvement, and when you stick that on the Solex carburetor, the smooth bore actually does line up pretty well with the Solex intake manifolds. Now the one problem these kits have is that the particular gasket they use here is not the right size. The hole's too big. This hole here in the center is too big. I don't like using these gaskets, so I don't use these gaskets. These ones that go between the top of the adapter plate and the carburetor are fine. They work okay. No problem with these. But the other ones suck. So what we do is we go to our top end gasket set and we get out 4 of the Solex gaskets that are normally used to get on either side, actually 8 of these things, normally used on either side of the insulator block on Solex carburetors. And we put them between the Solex manifold and the adapto plate. We don't use the ugly, useless Weber carburetor gaskets that come in the kit. We use these instead. Now you can put mucilage on them, but I don't like to do so. I find there's very low chance of leaks anyhow. We get out the nuts and bolts from the kit, the Weber kit, and they are, we find, the same type of Allen head bolts that we used on the pressure plate. 6mm Allens, conveniently enough. You already have the wrench. They go in the countersunk holes in the adapto plate, like this. Now some of these adapto plates may have been machined off a little bit, so the trick is to put all 4 of these bolts in place like you see it here. Screw them each bolt down a little bit because we want to screw them down in turn. If the jig they use is a little bit off, we find this is the only way to install this adapto plate, but short of machining down the bolt heads all the way around so they will fit in. In fact, this particular adapto plate's not too bad. Looks like it's going to make it. You got to make sure after you tighten these things down, though, that the bolt heads do go below the base of the adapto plate. If they stick above the base of the adapto plate, remove the bolts and grind them the heads down so they stick below the base of the adapto plate. Otherwise, you'll be sorry, because they will, if they stick above the adapto plate, the Weber carburetor will not fit flat. If it doesn't fit flat, you will end up having a problem. And the problem is an air leak. So make sure they all 4 of the Allen head bolts will in fact fit below the top of the adapto plate. Okay, it looks like we win this time because it looks like all 4, if we can get this one down, are going to fit below. Yes, it is. How about that? Thank you, Porsche gods. Okay, tighten them down. We don't want to overdo this. We are screwing steel bolts into aluminum intake manifolds against an aluminum adapto plate. So it's best not to redo them, or not overdo them. Okay, we'll take a slight break now. Okay, we've got the all 4 of the Allen head bolts that hold the intake manifold adapto plate, the intake manifold tight, and they're all below the surface of the adapto plate. Take the 4 studs that come in the adapto plate kit and screw them into the intake manifold adapto plate. Don't screw them all the way down. Screw them in about halfway to 2/3 of the way. If you screw them all the way in, you won't have enough stud left to put the nut on. That's a minor defect in these adapto kits. I've written them letters about that, but they never seem to listen to me. They think they know best, and they don't. So screw them down to where they're about 2/3 in the adapto plate. And then you can use the gaskets they provide, which do work okay, except the holes are too big. These holes are bigger than they should be to fit over these 8mm studs. It's ridiculous to have 2 big holes. I may make up my own gaskets and make kits up that have the right size holes. The reason is that these are a problem is if they go the wrong way, they'd actually uncover or actually go over to the area where the other 6mm Allen head screw is, and if they do that, they can cause an air leak because that goes to the outside world. So you got to make sure you twist them to where they don't cover. So when you put the Weber carburetor on, you don't get a leak. So make sure when you put these on that they're up against the stud in such a way as there's no chance for a leak between the stud area and the indentation of the Allen head bolt. Now the way to avoid that is take some red RTV, General Electric type, and stick enough in the Allen head bolt so that when you put the gasket on, it will squeeze a little bit out, but not much, and you can paint that area there with aluminum paint so everything looks kosher. And that will also prevent leaks. I just don't understand why they couldn't make the right size hole here. It's no big deal, but they don't do it, and it annoys me very much. I'm going to make up my own gaskets for these things. I'm sorry, I don't like these. We go to the other side, and the 4 Allen head bolts and our Solex intake manifold gaskets. We do not use the gaskets that come in the adapto plate kit because they're inferior. They also have another problem too. Besides having the inside hole too big, they've got 2 holes here. You don't need 2 holes here. It's ridiculous to have 2 holes here. You only need 1. One for the 1 Allen head bolt that goes through everything. These things are ridiculous. Throw them away. Don't use them for anything. Put the Solex intake manifold gaskets, arrange them over the stud holes so they're very nice. Put the adaptive plate on carefully. Like I say, you can use mucilage if you want to, but I don't. That way you can get them off easily. And screw the Allen heads in, all 4, before you tighten any one down. And that way you can be assured that everything will go in pretty effectively. Get out your Allen head wrench. Tighten them down 1 turn here, 1 turn there, 1 turn everywhere, and do it all evenly. If you don't do it evenly, the adapto plates are sometimes off enough, like I was saying, that you can twist the adapto plate and not allow the other bolts to get in. These adapto plates in 1986 seem to be a little better done. Maybe illegals coming in are a little better educated now, I don't know. Okay, but get them all fairly nice and tight, evenly. Ah, there's one that's kind of tight. You can put the secret sauce on the edge of the bolts to lubricate things. That does tend to help. Or if you have to, you can grind the side of the Allen head bolt down so that it will clear with no problem. But these seem to be pretty much in good shape, better than the average adapto plate. I like to provide the best Weber kits with the best adapto plates and the best Weber carburetors, and let me tell you about Weber carburetors. This year has been terrible. They've been out of Weber carburetors for the entire summer, when the biggest demand is, of course, naturally, by Murphy's Law. And the Webers that finally did come in to this country, the United States of America, were the wrong Webers. They were used on Fiats or something. They have 2 inlet lines. They have all kinds of strangeness, including a working enrichment circuit for a choke. They have 31 millimeter Venturis rather than 28, which is actually beneficial. And what I'm going to do is use those Webers on this engine. We're going to make them work right for this engine. 31 millimeter Venturis is very close to the Solex original equipment 32 millimeter Venturis, rather than 28 millimeter Venturis of the regular 40 IDF Weber. What we have on Weber carburetors is the 40 IDF. If you want to tighten these things down, you can take a 13 millimeter wrench, put it on the Allen, and it gives you much more leverage. Tighten things down. The 40 millimeter Weber has a 28 millimeter Venturi usually, and the 44 millimeter Weber has a 36. And that is either too small. 28 is smaller than the Solex 32. It's the same size as the Zenith, but being a Weber they flow better. And the 44 Weber has a 36 millimeter Venturi, which is somewhat too big. I wish Weber would make a 32 millimeter Venturi carburetor, and I think I'd be very happy then if they had a 40 millimeter bore. It'd fit on the adapter plate, they'd fit on the Solex intake manifolds, they wouldn't have interference with the sheet metal, the Solexes don't have. The Weber manifolds, intake manifolds, don't use unless you have 44s. The reason for it is not only is there interference with the vertical sheet metal and getting the spark plugs out would become a real pain, in fact almost impossible unless you pull the engine, which you don't want to do to change the plugs. So I don't like using the 44, I don't like using the Weber manifolds that come with some people's Weber kits, simply because they're used only with the 44s. And you use the 44s only for high performance applications. Street engines are best served by the 40 Weber. These new 40s though have 31mm Venturis. And because they have 31mm Venturis, they're 3mm bigger than the 28s of the 40 Webers. I'm going to try them out and see how they do. In fact, we'll try them out on this engine. But they have a problem. They have a T inlet line that has inlets on both sides, which means you got to pull one inlet out and plug it. And the inlet line is pressed in, so you have to unpress it out and then tap it for a plug. Lots of fun. While we're here, pop up the oil filler can. Take the oil filler can gasket, which was munged up here a bit from 100,000 miles of use. Make sure you clean it off with WD-40 so no dirt and crud gets inside. Use a fairly clean rag if you have one left. And then the good side, which is up against the can top, put so it seals. And then you can get another 100,000 miles of use out of this thing, like so. And now we're approaching the finale here. All we have to do is put on the Weber carburetors, check the timing, get the fuel line and linkage set up, and we'll be all set. Put, of course, the dipstick in, and put the drain plate and oil drain plug in place. And we'll do that in a few minutes. The screen and sump plate are of two different kinds. This is the type with this engine. It's got a small hole to accommodate the small pickup tube of the earlier engines before '63. The screen is a very fine woven screen with an appropriate hole for that type of early smaller pickup tube. Okay. The post-1963 engines have a bigger pickup tube and therefore need a bigger hole in the magnet, like this. They take a screen likewise with a bigger hole, appropriately. This screen is a much less fine screen. It's a coarser screen. Really, to me, it's not much of a screen at all, because those holes are about 1/8 of an inch by more than 1/16, something like 3 or 4 millimeters by 1 or 2. And they really don't screen out much of anything. This screen is a much finer mesh screen and will actually do something, help keep particles out of your engine. Because once the particles get past that screen, I'm sorry, but they're into your engine. The filter we have is a bypass filter, not a full flow. And if it gets into the pickup tube, it's going to get to the bearings. Anyhow, we'll be using this screen here, plate. And the way it works is you go to your lower end gasket set and get out 2 of the sump plate gaskets. There are 3 in the lower end kit because Super 90s take 3, but we don't have a Super 90 here. You put one gasket on. Helps to have all studs in the sump plate. If you have some bolts, you can actually take the bolt out and drain the oil, which is good. It makes life a lot easier. But if the bolt falls out, then all the oil will drain out too, and you'll have a problem. Push the gasket over the studs. Sometimes they're a bit tight in this situation. Screen, though looks dirty, is actually clean, just old. We didn't plate the screen. Stick it over, push it down. Make sure the pickup tube protrudes nicely. Put the other gasket on. Sometimes you have to play like it's a third-piece seal and get it all over the studs evenly. And of course put the nice CAD-plated sump on. That goes on fairly easily. Get out 10 6mm washers. Of course, stick them on. That's pretty straightforward. Keep the smooth beveled edge to the outside and the sharp edge to the inside, and it makes them look a lot nicer. I like to use the new nuts on the screen and sump plate. They look very nice when you're changing the oil. They come off nice. The threads are in good shape. That sort of thing. If you have any studs that are messed up, you can remove them by either the double nut technique, if there's enough stud to get off, get both nuts on to get it off, or by just a pair of vice grips, usually. In some situations, you have to weld a nut on and get them off that way or use a stud remover. But they usually come out. They're not held in nearly as tight as the case studs are. So once we get these on, we'll tighten them evenly. And I won't really bore you by showing you how you tighten up each one, but it really does help to go alternately back and forth and work your way from the middle to the outside. Middle of the stud area here to the either end. Keep the manufacturer's logo on the outside if you can. It makes for a much nicer arrangement. And there we have them all on. Okay, we won't, like I said, we won't bore you tightening them down right now. Put in the drain plate, or the oil drain plug, which is this. We've CAD plated it. Everything on the engine. Non-critical fastener, we will CAD plate. Don't overdo this. This is a pipe thread. So just get it tight, but don't lean on it, or you can have a heck of a time getting it back off again. About like that. So let me tighten these down, and we'll go back and put the carburetors on and the rest of the odds and ends and fire this engine up. Okay, we got the plate pretty much tied down now, and this is how you tighten it down in this pretty much this sequence here. When you do fire up a new engine, like I was saying, you got to change the oil at between 30 and 50 miles. Then again at 300 and 1200 miles. You really want to do a nice job of breaking it in. You do that by dropping this plate. I know it's a pain because of the 10 nuts. It takes some time, but it doesn't take that long. But you got to drop the plate each time and clean the screen and the magnet, because there'll be some magnetic hair on the magnet, that is iron particles from the rings, etc. There may actually be some crud from both crud that got into the engine and crud that's formed in the engine. You want to get it out. The first oil change is most important. That should occur anywhere from like 10 miles to 50 miles, no more than 50 miles. Second one should be around 300 miles, and the third about 1200 miles. We'll tip this back now and put the carburetors on. Like I was saying, we're using Webers, and we have them right here. This is a new type of Weber. It required some modification to work. It had two fuel inlet lines here. One just like that on this end, and that's patently ridiculous. You only need one. In fact, it's hard to deal with the second one. So we took it out, tapped the area here, and put a plug in it. These velocity stacks are actually from Delordo. I happen to like them, and they serve well on Webers. There are some plugs here. These are vacuum lines that this particular Weber has. This is a different model Weber. It's got a non-adjustable accelerator pump except with two pins, usually for not enough and too much, or too much and way too much. But there's been a great Weber shortage in the summer of '86. Net effect being these are the only ones I can get my hands on for this engine. The big advantage of them is they have 31mm Venturis, which to me is almost ideal. I'd like to have 32mm Venturis like the Solex 40 PIIs have, but this will do just fine, I think. I want to try them out and see how they are. Linkage arms are ones I get. I don't like the ones supplied by Weber anymore, or the Weber importer. They're pretty lousy. I like these better. The balls are pretty nice. You have to do a little trimming sometimes here at the stop, but it works all right. What else can I say? These Webers come with a working fuel enrichment circuit. Most all Webers just have a block-off plate like this, and I removed the fuel enrichment circuit mechanism and just put a block-off plate, excuse me, since Porsches don't have any chokes and don't really need them. We don't need them either. So all in all, they look like fairly decent carburetors now. You got 3 vacuum lines, a couple vacuum line takeoffs below the throttle plate and some above it. For operating either vacuum advanced or retard distributors, we plugged them all. The idle mixture screw is recessed rather than easily accessed, so you have to get a small, thin screwdriver to fit in there. But overall, it's not a big deal. We'll put these on, see how they do. And in fact, we'll put them on now. So what I have discovered on these gaskets, as I pointed out, is the hole is too big to fit over the stud. It wiggles around too much. you can get either some RTV or some Loctite Formaseal and just put a dab on the top of the 6mm bolt Allen head, just to fill up the Allen head. We will clean this off, clean off the excess. Just want to have enough to where the gasket will force out the remainder and we don't have too much excess forced out. It's not the most convenient tube I've ever seen. You take and just leave enough left so that the gasket, when tightened down, will force it out. And not inside the carburetor, but in fact inside the manifold, but outside the manifold. This Loctite Forma gasket isn't too bad. The GERTV also works fairly well too. Smear it off as smear it around a little bit if you want to get it on the sealing area. That sometimes helps to seal everything too. It doesn't really hurt too much. Put the excess around there. When you put the gasket on, make sure that you rotate it around the stud in such a way as it tends to cover the Allen head bolt area. If you just put them on randomly, you may have a carburetor air leak. Get out the proper side. This is the proper side. We, out of necessity, just ran a little U-tube between the two vacuum ports, just so they will temporarily, we get the right plugs for them, but we don't have them right now. It also helps now to get out the proper screws, nuts actually. You can use either 12 or 13mm across the flat. Again, 13 is a little more common these days, so I think we'll be using 13 on these. You can use either the thin washers, a smaller outside diameter, or the thicker ones. The thick ones are kind of hard to get anymore, or the large outside diameter washers are hard to get. So we'll just use the thin, regular 8mm gaskets. Put the nicest looking nuts towards the front. It also helps to use the one that's in the best shape here. This is the hardest to get off nut, and you'd like to get the best grip on it possible, so use the nut in the best shape there. Make it look as nice as you can. It's a little tricky getting to some of these, but it's not too bad usually. Tighten them down evenly, of course. That's the trick of the trade, is to make sure everything is being tightened down evenly. And we will tighten this down for you. May as well do it now. Show you how one goes on. Put the other one on, and then we'll adjust the linkage, set the timing, put the fuel line on. Note that I like to have the fuel lines point towards the front of the car. That way you can use your stock fuel line. You have to cut the banjo fittings off, so you might want to pick up another stock fuel line at, say, a swap meet or something. Get the nut, it's hard to get to a nut as tight as possible with your fingers before you use the wrench. Minimize the number of 8 turns at a time that you have to do. Let's see, if you're using the manifold adapter plate, that will space the carburetor out enough to where you won't have any interference problems with that choke block-off plate that we discussed. If you're using just the Weber manifold, then you sometimes have linkage or interference problems with the choke block-off plate hitting the spring plate on the other side. I'll show you that in a second when we get this one snugged down. It's pretty good. On the other side of this, when you're going to put the right-hand Weber on, the spring plate is held by 3 bolts, hold the top linkage crossbar. If you put the carburetor on, you'll find this one, get a close-up of that, this one screw that holds the block-off plate can come awfully close to this nut that holds the spring plate. In fact, if, get it over a little bit, if you're using the Weber manifold, which actually rests somewhat lower, the adapter plate raises these things up. If you're using the Weber manifold, this screw will hit that nut and cause great problems. In fact, when you try and tighten the carburetor down, you may bend something, or put undue stress on the spring plate, or both. So be careful when you put these on, look at everything, and make sure you have no gross interference problems. So get out your gasket material. Again, put a little on. That's a little bit too much on there. Move some to the other side. Like I said, this is not the finest applicator I've ever seen, but it'll work. The GE RTV is actually a little bit better. You can control the amount a little easier than you can with this tube. I thought I'd try something new and different with the Loctite, since I do like Loctite. I like their products. But we can spread some of this around and act as a bit of a gasket sealer too. Don't overdo it. Just get enough on that nut so that when you tighten down the carburetor mounting nuts, that you will then have material squeezed out to the outside and not overly. We'll go around afterwards and clean all this good stuff off. Again, arrange the gaskets so that they will seal off over the top of the 6mm Allen head. Carefully arrange that. Put the carburetor down. Get your... Alright, again, use the nicest looking washer. Washers on the front, the other ones on the back. Note how much the studs protrude above the carburetor. If we had tightened, inserted the studs a little more than we had done when I was discussing that you might find that you wouldn't have enough meat on the stud left to grip the 8mm nut. But since you're warned of that in advance, you do have enough, and everything will be cool. Alright, next step after we get the carburetors on, you either do the linkage of the fuel line. I suppose at this point you may as well do the fuel line. And as I was saying, you should get the stock fuel line. That's one I like to use. If you don't want to use your stock fuel line, it's okay. Just get a brass T and make up a fuel line out of rubber hose. I like to use the German rubber hose. I find it fits the Porsche lines the way it's supposed to. Lasts a long time. Looks pretty good. The American rubber hose is a lot bigger. Actually, the wrong inside diameter. A little bit too loose on the Porsche metal lines. And when that happens, you can sometimes get leaks. I would use clamps on everything. I've seen some engines come through with no clamps on the fuel line, and the fuel pump can produce, a good one, can produce about 4, 5, 6 psi, pounds per square inch. And you can blow off fuel lines that don't have clamps on them. You blow off a fuel line that doesn't have a clamp, and you end up with a massive gasoline leak. You can pump the entire contents of the gas tank onto your engine. You got bad spark plug wires, you can have yourself a fire insurance total just waiting to happen there. No problem. Of course, it is a problem for you and your insurance company. Okay, get the nuts snug, but don't really lean on them. You don't want to distort the base of the Weber. Like so. Clean off the goop that leaked out. We can actually paint this the red goop after it dries with aluminum paint. That way you can't really tell that any goop has been used at all. Okay, so let's get the fuel line. Put the fuel line in now. This fuel line's been CAD plated. We've blown through it either with water or air to make sure there's no bugs taking up habitation in it. To use the original fuel line on a set of Webers, you have to cut off the banjo fittings. The best way of doing that is to arrange it so that it would clear everything back here, be somewhat aligned, and you want to chop it, put enough room for the fuel hose. Usually means you have to chop it just before the bend, right at the bend. To do that, you get out a tubing cutter, which is available at Sears or many other places. And it's very simple. You put the tubing cutter on a tubing that you want to have cut, hence the name, about where you want to have it cut. hold the tubing, rotate the cutter every turn, tighten the cutter handle down a bit, and pretty soon, voila, nice smooth cut. Likewise, arrange the other side the way you want it. Again, you'll find right about at the bend is where you have to cut it. It's kind of hard to cut it in the bend because the tubing cutter is really not designed for that. So cut it as near to the bend as you can. Again, every turn, crank the handle down just a little bit. And before you can say Jack Robinson, you get it off. Now I like to use fuel filters. Actually, this piece here is the vestigial remains of the flexible section of the front line, and we have to remove it too, so let's get that off. And that can be cut as close to that flexible connection piece as possible. You want to save as much line as possible. Just takes a few turns, turning the handle clockwise, like that. What I find is you need a little bit of tubing. There's a little bit of tubing. Good German gas hose. You need a pair of tin snips. A pair of tin snips are fairly readily available. I found you need about 2 inches of tubing for connecting the fuel line to the carburetor, so you can cut off 2 2-inch sections. You need about 6 inches of hose for connecting the fuel filter, etc. So I cut off about 6 inches. Then you don't have to have this big roll of tubing around. That's about all you need, except for the inlet fuel line. Alright, so the first thing to do is do a trial fit of everything. So you take your hose connections, lay the connector here, the fuel line on this side, take off the plastic tube protecting the Weber. It sometimes helps spray WD-40 on things to get the fuel line over it. Push it on. That's not too badly arranged. Sometimes you have to bend the lines a little bit to clear everything. That's not too bad. Take the other one. Pardon me. Put the piece of fuel line you cut off over this other line. Take off the plastic protector. Sanitize for your protection. Push on the fuel line hose and see how things line up in the front. Now they don't line up. Here we have a ways to go. You can use some of the tubing that you just cut off for other pieces necessary to make the connection in the front. Let me show you how that's done. Here's your tie-down clamp, which while we're here we should loosen a bit. And you see these pieces don't make it, so what to do? So what you can do is get out one of the longer chunks that you chopped off and cut off about 2-inch section or so of it. If you can't hold this, you can actually put a screwdriver through, or a pair of pliers will sometimes do it, or our old favorite, the intake valve, which serves a multitude of purposes here. And cut off about a 2-inch section. Idea is to put the gas hose on such a way as this clamp will tighten down with a solid metal fuel line in the center of it. So what you can do is then take enough fuel line to fit from one side to the other, cut it in the middle, put fuel line on from either end. Here we're going to need the WD-40. Really helps. Put some WD-40 in the fuel line, spray it on the gas line, screw it on halfway, screw the other end in halfway, and then you can stick it through like that. And the clamp will actually then tighten down on fuel line hose. Now I don't trust this clamp to actually stop leaks, so I'll put regular clamps, hose fittings on either side to make sure it'll tighten down. Loosen it up a little more to get it through. Put the joint about in the middle of the band. And leave enough, you can feel the fuel line on the inside, leave enough to get a clamp on either side. Arrange things. Put the other half in this side. Actually, it's a little bit longish here. We can trim it. See how this side is? That's about right. You can trim this just a little bit. I like to use CAD-plated hose clamps. Best to put 2 of them on. 1, 2. I like to put the screws all in the same, pointing in the same direction. I like to have them downward. Put that on like that. Make sure you have enough material to grip it reasonably well. Get out 2 others of the CAD-plated persuasion. Stick them on like that. Stick it in like that. We'll come through now and tighten all these things down, but you see the general idea. Once this is all arranged, now you can tighten this down to support everything. When you tighten the clamp down, it won't squeeze the fuel line, shut off the fuel flow, because we have a piece of metal line on the inside. Now's a good time. Take off this side, put on 2 clamps. With the nut, the screw down. Little WD-40, never hurt anything. Push them in. Get out 2 more clamps. 1, 2. Go to the other side here. Pull off this side. Put the clamps on, screw down. Now here we have a little bit of a mismatch, so what we have to do is get this fuel line a little further into here, which isn't too hard to do now. We can wiggle and twist. That's where WD-40 helps. There we go, got a little bit too far, so we can pull it out a bit the other way. That's just about right. Put the clamps on. Put the fuel line on. Go around with a screwdriver now and tighten everything down. We'll do that all at once so we won't miss anything. Go around the front of the engine. Take another piece of fuel line. We're going to put the fuel filter in. Speaking of fuel filters, I like to use a transparent fuel filter. One that you can see if there's gas or not inside. Because if you can see there's gas, at least you know you have gas inside the filter. If there's no gas in the filter, there might not be gas in the lines. Pay attention to the arrow. There's a little arrow there. We can get a close-up on that. That little arrow tells you the direction of fuel flow. It should be from this side to this side. So don't make a mistake and just slap it on any which way. Okay, the fuel filter I like to put about here. I like to filter the downstream side of the fuel pump. I found out from the nuclear business a long time ago, that's what you should do. Never filter the inlet side of a pump. Always filter the discharge side. So we get a couple more pieces of fuel line out. Cut with our appropriate eye to the right size. And we'll cover this ugly piece that had a piece of rubber on it and didn't get plated. A little bit of WD-40 there. Put the rubber over that section that's not been plated. Make sure the fuel filter will fit in. Make sure the arrow is pointing the right way. Get out some more of the nice CAD-plated clamps if you still have some left. And I think we have a few left here. We do. And again, I like to put all the screws, well, that's a fairly ugly one, let's get a better looking one, there's one there. Put all the screws so they face downwards. Just, well, let's see, we're going to be putting it in that way. So we'll do that one like that, and that one like that. And these two will go like that and like that. So we'll stick that side in first, and then that side. And now we can go around with a screwdriver and tighten everything up. And our fuel line is then installed. Just it takes about 5-10 minutes to do that, no problem. Now the carburetor linkage is next. That really helps if you have a good selection of linkage rods. If you don't have a good selection of linkage rods, you may have some problem getting all the various linkages arranged right, but of course Maestro does have a goodly selection of linkage rods bought over the years at swap meets. So what we'll do here is we'll select some of the better ones and see if we can get some to just attach. Use the nicest looking one on the top here and the not so nice one down there at the bottom where you can't see it. Alright, see if this is going to come close. It is. You need a long linkage rod for the crossbar in the front. So we'll find a long linkage rod. There's a long one. The linkage rod in the front has the ball sockets arranged so they face the same direction. Of course, on both left and right hand carburetors, they'll be facing in different directions. This is how you tell a long front linkage rod from the others. The balls face in the same direction. So we'll put that on. On the trial fit, you don't have to put any lubricant on the balls right now because you may not be using that particular linkage rod. So now we'll go around and see if we can luck out and find the right ball that'll fit on that one. That's not it, but it may be a possible one. See which of the others here I can find quickly for us. See if this one, how close this one will come. A little bit too long, but it fits. It sometimes helps to have this free so you can adjust everything. Okay. That's a little better. A little bent, but we can straighten that out without too much effort. Okay, select the right ones, and then you can adjust them by loosening the nuts, and that's usually best done by taking a pair of vice grips and holding on to one of the nuts and using an open-end wrench in one direction on the socket. Now you can, of course, put the right wrench on here. That's probably really the best way of doing it, but in case you're out in the boonies, it's nice to know the wrench technique works. Let me find one here that's a good candidate. Some of the linkage arms have a welded nut here, which doesn't help you to remove things. Unless you do the technique, you can take your big universal wrench, tighten it down on that weld nut, take your 10mm open end, stick it on here, and turn. Now there are left and right hand threads on some of the linkage rods, so be careful when you try to, what you think is tightening it down may actually be loosening it. This particular situation, this is a regular right hand thread. The other side, though, looks like it's a left hand thread. And let's find out which one it is. We'll try and take it off. We find out we're tightening it. So we then reverse the procedure to loosen. And you see, I'd be tightening the right hand thread, but I'm actually loosening this one. It works the opposite way. Now we've got this one loose. We can put it anywhere we want to. And now let's see if we can put it on this side. That fits over fairly nicely. We need to lengthen it, which we can do this way. It's a little bit too long, so I can tighten down the one that's extended the most. Still too long. And put that on like that. Make sure we have full throttle, which we do. Make sure both come back about the same place. They do. So far, so good. This one here on this side, linkage is actually being held open somewhat. We'll put return springs from the holes we drilled here. These linkage arms come with the holes drilled in the wrong place. Another example of the incompetence running rampant through the United States these days, or Mexico, wherever these things were made. It helps to loosen these up too, so you can adjust either side. It's the same type of arrangement, so we get out our handy-dandy little universal metric wrench. Put our 10mm open end there, and baby pops right loose. Turn around the other side. Just have to do one side, but if you loosen both sides and you have a left and right hand thread, there we go, which this is, so both linkage rods now are left and right hand thread. Then by loosening both balls and twisting the middle part, the rod part, we can actually lengthen or shorten the rod continuously rather than in discrete one-turn steps, which we'd otherwise have to do. This makes for a much finer adjustment on the carburetor and is really the way to fly. So again, put the nicer looking ball, which is this one, on the more visible place and get everything so it will now adjust properly. Still too long, we want to shorten it, so we take the right hand threaded piece and screw it in to shorten it. It's not too bad now. There we go. We're getting there. Okay, next step is I'll tighten down the screws on all the clamps. We have still a fuel inlet line to put on, but that's fairly simple. Then just go on like this. Now the plating process sometimes messes up the hose, the gas line, so to be safe I cut these off and then put a regular line on in place. Okay, so we'll take a break now, and I'll come back. When we come back, I'll screw down all these screws here, so you won't have to sit through that. At that point, we'll be about ready to put some rubber in the sheet metal, oil in the engine, and fire it up for you. We've tightened up all the clamps, little hose clamps that hold all the fuel lines in place. We've also gone around and made sure we've tightened up all the 6mm bolts, including those two down here, that hold the little plate that the dipstick shroud screws into. They're hard to get. In fact, the breather can should be removed to get to those two 6mm bolts. So make sure you get them. Now we're going to put the muffler on. And this is a B-type muffler. Big and bulky, but it works and lasts a long time. B-type, BC912 mufflers, American heater system, have pipes on about 3-inch centers. A mufflers have pipes on about 1-foot centers. One of the main ways of telling the difference. We're going to put this on now. When your muffler comes through, you'll find usually one or more of the pipes will be dinged up a bit. Best way of dealing with that is to put a screwdriver handle into it and crank it around so that you can pry out the flutes. And if you can't do it with a small type, you can get your big mother out, and by God, you can do it with that. And get the flutes so that they're all out sufficiently to fit over the J-tube, not crunched down at all. Check the other side. It's not too bad, but it should be pried up a little bit. We can do that. Pry them up evenly on all 4 flutes, like that. Then get out the 2 remaining exhaust gaskets from your top end gasket set and put them over the studs of the head. Helps if you put them over evenly, like that. Likewise on this side. Get out your WD-40 can, lube up the exhaust pipes, inlets, the muffler, lube up the J-tube on the outside. Every little bit helps. That helps to get out CAD plated clamps, which we have here. These are used clamps, they're not in the finest shape, but new clamps are getting hard to find. Put the clamps over the J-tubes now. And don't forget it, they're a pain to put on otherwise. You have to, if you put the muffler on first, you have to pry them up, and then they're a pain to get closed again. Pardon me while I step in front. Feed the right-hand side, lower J-tube, pipe over the J-tube, push it on a little bit, come back to the left, feed that on. Sometimes you have to squeeze the pipe, sometimes you'll have to take it off again and do a little more prying on the flutes to get everything arranged. This can be kind of repetitive and annoying, but it is required sometimes. A little more WD-40. This time I'll try the left-hand side initially. Put the left-hand side on, like that. Attempt to get the right-hand side on. Wiggle it back and forth on the J-tube to expand the flute evenly. You can use the J-tube as a mandrel. Try the right-hand side again. And there we go. Use your body to force everything over. Come over here to the right-hand side. Now sometimes you'll find that the pipes, muffler pipes, may not exactly line up. In which case, as we have here, you can find that it's sometimes best to redress that area with either your flexible hammer or with the 3-pound sledge. So, take this off, it's on the ground, whack, 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 and try it again. These mufflers, I've noticed, have gotten somewhat harder to install over the years, but usually they will go on with only minor differences or minor difficulties. Actually, we would have what would be considered to be a minor difficulty, not a major one. You then get out 4 of the 8mm nuts. Use the best ones on the top side where they're visible. Screw one on each side. You want to tighten the muffler down evenly. Put the not so good 6mm nuts on the bottom nut studs. Best technique I've found in tightening the muffler is first to tighten down top nut about halfway. Go to the right hand side, tighten the top nut down about halfway. I like stock mufflers over any type of other muffler. The extractor systems may sound good until you drive cross country in them. And it's kind of like being inside the kettle drum during the 1812 overture. I learned a long time ago also that the stock muffler is really very quiet, especially with the S-tubes hooked up. In fact, so quiet that the cops really don't notice you very much. You can be doing pretty exotic things, and you let up on the gas, and when you go past the cop, and he doesn't even look up. You try that with an extractor, and he'll hear you coming for 2 miles. Okay, so now I've got that side down a bit. Come back here and tighten this side down some more. This is actually beginning to look like a fairly decent Porsche engine, I'd say. Considering what it was like before, remember the before picture? It's kind of amazing that you can take an engine like that and make it into something like this. Now, it's also amazing too that if you just have the muffler hooked up like this, without the S-tubes to go to the bumper, through the bumper guards, I actually bend my S-tubes so they point towards the ground. That protects the bumper guard from being corroded by the exhaust fumes. That just have the muffler without any S-tubes that you can have a backfire when you let it off on the gas when you're cruising, say, down the freeway or on the road or something. That's caused by not having the S-tubes in place. Very simple problem to rectify. So if you do have a backfire, when you let up on the gas, check your S-tubes to make sure, S-pipes to make sure that the one or both has not fallen off. Okay, now make sure this is the hardest nut to get to here. You sometimes have to use a socket on it to be sure you get it. We have a couple choices of wrench, so we can usually get this without too much effort. But a socket will also get to it. You actually fit a 12mm socket in there. Next step would be tighten down the clamps. You need two bolts and nuts. You bring the clamp back over the flutes, which, since it's on the engine now, is a lot easier to do than if you're trying to fit it over the engine at this point. You can bend it up a little bit to put it over the flute. You can put these clamps on the muffler part, but when you're messing around with the muffler trying to get it on, they'll fall off. You can take a pair of vice grips, torque the vice grips down like so, and use them to torque the clamp down successively. In fact, if you're really good, you can use these vice grips to torque the clamp down as you put the bolt through, and then tighten the nut down. Put the clamp about 2/3 of the way on the muffler and 1/3 of the way onto the J-tube. And I like to use 13mm wrenches or nuts on this because that is the size you can find when you're out in the boonies. And in case you have to replace the muffler, so you can always get a wrench that fits. 1/2-inch wrench is close enough to 13mm. You can actually use it. So you tighten down these muffler clamps, and if these muffler clamps are not on, you can also get a backfire from an air leak here at the muffler. Let's get out two 13mm wrenches now, and very quickly tighten these muffler clamps down. And as you can see, or maybe you can't see, but take my word for it, we're almost done here. I'll show you how to check the timing at this point. This can be part of the material that was supposed to have been in the tune-up tape. For that, we need our volt-ohm-meter. It's an easy technique to use. We crank the engine over until it's a top dead center. We take the positive lead of the volt-ohm-meter and stick it in some convenient place along where the coil is, some place where it'll hold. Or we can use our hand. The black can go to common, ground, any place. And we can put that usually in the distributor clamp area. And we'll hide it here in the back side of it. Or we can put it any place where it's a good ground. It really does sometimes help to have three hands here to do everything. But if you get things in the right perspective, you can usually get the positive lead so it will stay, though not all the time. Now that we're trying to do this to show you that, it probably won't stay. They're small enough you can stick them through the little holes here, but you really can't do that. Anyhow, what we'll do here, to show you how this game is played, with one hand, the bracket here, the coil, is actually a good place too. You can hold it really good. We can hold it here, and with our third hand crank the thing over. Now we measure the resistance. We first got to check to make sure that everything's a top dead center on number one. Pop the cap off. See where the rotor's pointing. It is pointing to number one. Good. We're all set. Alright, so turn on your VOM. Crank the OT mark back to where it's about 2 inches to the left of the mark in the case. Set the wrench to go the other way. Make sure that the resistance when touched, when the touch the two leads, that you get zero resistance here essentially. Okay. And when you put it on the coil from the hot wire to ground, either side of the coil to ground. You'll show a 0 resistance. That means the points are indeed closed. You can put the ground terminal between the capacitor and the body of the distributor, and then it'll stay. You can hold the other one up against the coil. And you slowly crank the engine clockwise, and when you see the resistance go to infinity on that side, that's when the points just open. Okay, let's try that again. There we have 0 resistance, and then when the points just open, it drops down. It should go to infinity. Actually, we should put it there on that scale. Back it up again. Boom, infinite resistance. When you do this, you can check the timing mark, and you see here the timing mark is just about lined up with the notch in the case. That's top dead center. For initial fire up, that's not bad. Let's do it really slowly this time and see where we get. Beginning to open, there we go. Here we got about 1, maybe 2 degrees static lead. That's not bad for fire up. I like to see something on the order of 3 to 5 degrees static lead with the 050, which this is. But you'll see the technique we used of aligning the mark in the rotor with the mark in the body of the distributor is very accurate. Leads to very accurate timing if the points are gapped correctly. Do this one more time for you so you can really see it. There we have essentially 0 resistance. We slowly crank it over. Boom, infinity. Boom, just about top dead center, maybe 1, 2 degrees advanced. That's fine for fire up. So now we'll disconnect the leads on our VOM. Timing's pretty well set. Let's put some oil in this. I'll show you how to rig up the firing device, which is nothing more than part of a transmission hooked up to a starter. We'll attach that. One more thing we have to do is put the rubber in. There's a do it now. I like to use the Stoddard imported car rubber because I find that the rubber they have has the right cross-section to fit into the sheet metal easily. There are other rubbers supplied by other people, inferior rubbers, that have a talcum powder covering on the rubber. And they have too thick a cross-section. It's a real bear getting that rubber into the grooves in the side horizontal pieces and the front and rear plates. Stoddard rubber, though, doesn't have that problem. It also comes semi-pre-cut. 2 pieces for the side horizontal pieces, and 2 pieces for the front and back shrouds. So we won't use them right now, but we do need the side horizontal pieces. Take your big mother screwdriver and go to the lip. Let's get a shot of this. Go to the, I'll turn the engine a bit so you can see it more. Go to the side horizontal piece and pry up the lip here. In fact, this lip is in excellent shape. We don't have to pry it up much at all. Just get the start area where we're going to put it through, either this end or this end. Pry it up, and I'll do it from the back to the front. And take 1 piece of the rubber, take some WD-40 because it'll evaporate nicely. Spray the groove, spray the rubber with WD-40. And you may have to use a pair of pliers or you may not. Let's see what happens here. Look at that, isn't that nice? It goes almost all the way through by hand. Get a pair of pliers out and pull it. You can then adjust it from pulling it from the back till it's about flush there. The rear plate, when it fits in, will mate with this rubber and it'll look like one piece. You got to cut it off though, and you should cut it off perpendicular. So you take your cutter, cut it off like yay on the front. Let's see how the other side is like, what the other side is like. Get out the big screwdriver, you threaten it with the big screwdriver, and the chances are the rubber will decide to go in with no trouble. This one's a little worse. It's got a few more dinged in areas. So you try and pry it gently, not too far to crack the paint or something, but enough to get the rubber in. And the smoother you make this, the nicer it'll look. So don't just go gouging away with it. Okay, get all the little dings out of it if you can. It does actually help to do this before you have everything stripped, but very few people do. While you're here, in case you notice too much wiggling around, you might want to check all the screws to make sure they're tight. And this one was not quite tight. but it will be now. That one's pretty tight, I see. All right. Get the rubber, or the groove, nicely formed. Make sure the bottom's okay. Take your piece of rubber and WD-40, spray it in the groove, spray the rubber, like that. You start from the back or the front, doesn't matter. Oh, look at that, isn't that nice? Get out your cutter, crash bang, cut it off, arrange it. And if you want it to stay, you can take a rubber hammer and tap it a little bit. That tends to make the rubber a little stickier and bend the groove over. In other words, you can take a screwdriver, do the same thing, pound the groove in, wipe off the excess. That's how you install the rubber in the front and rear plates. You got to pry up the groove on the front and rear plates to get it all nice and big enough to get the rubber in, and then oil both the groove and the rubber and pull it through. Sometimes you have to use vice grips on the rubber. They give you about 2 inches extra, so you can do that if you destroy one end of it. No big deal, just cut it off and it'll go in. Okay. I think what we'll do now is actually get some oil in here, get the dipstick in there, and fire this up before your very eyes and see if what we did was right. So hang on, we'll be right back. Okay, we've put 4 quarts of oil in so far. We add a 5th quart. I know you're supposed to, when you change oil, add only 4 quarts to it, but on a new engine with no oil in it, it takes 5 quarts, one to fill up the oil filter can and the oil cooler too, as well as all the passageways, etc. So put 5 quarts of oil in. Again, oil is your choice. I like using Pennzoil 2050. You can use whatever turns you on. But I like Pennzoil 2050. It's worked for years fine. Take out the dipstick, check it. It should be about 1 inch above the fill mark. Okay, that's the extra quart. And we'll check it again. In fact, to show you I'm not fooling you, I will check it properly. Wipe it off, put it back in, see where it is. Okay. Close up everything. I've got my super duper engine starter kit set up on this, and everything is now about ready to run. Clean off any drool that we made here. It's usually a little bit of drool. I'll show you how to put the gas in. Now you don't have to fire your engine up on the ground, you can fire your engine up in the car. But this is a neat technique for starting engines up that are going to be shipped out of state or whatever. Get a can of gas. Get an old fuel pump that works with 2 fuel lines. That's the suction side, it sucks. You put that in the can, take the other end, attach it to the fuel inlet line, like so. Take the top off the gas can, stick the fuel inlet line in, and activate the pumping mechanism with your hand. Eventually, you'll see gas coming to the fuel filter. Can you see that fuel filter there filling up with gas? Well, keep pumping because you got to pump all the fuel lines filled. You got to fill up the carburetors. It takes some gas to do that. And when you do that, when you get the carburetors filled with gas, you can also check for leaks. And in fact, we actually have a leak here. And that's coming from that line there. We can tighten that down. That's the inlet line of the Weber. It's a 17 millimeter. That contains a fuel filter. Oh, I'm sorry, that's a 19 millimeter. Okay. Wipe everything off. Make sure you have no leaks. Check the other side. If one leaks, the other one might too. Check all your connections for any gas leaks. It's a wonderful way of checking it without catching everything on fire. Oh, I see. It's coming out of the... Well, better to find it now. There's a little Teflon material on here too. I think we're all set to go, so let's hit the button. Not bad, huh? adjust carburetors. Get the idle stop a little bit off its stop. Screw things in. So the cylinder starts to die. Back it out a little bit. About right there. Well, how about that, Porsche fans? It actually runs. And this time, now that it has been fired up, we take the dipstick out and we find, lo and behold, the oil level is now full. That's why I say you should put 5 quarts of oil in your engine when you first fire it up. And that way you won't be a quart low after you've run it for a few minutes. So we'll put that back in. Now when it first runs, I want you to check top of the bolt here, the oil filter can, for any leaks that might occur. Likewise, the oil filter can top is very, very susceptible to leaks, especially on first fire up. Check the lines, both connections at the line. Check the outlet line from the filter. And check the oil junction block, which is, of course, over here in front of the distributor, for a leak either from the oil temperature sender or the oil pressure idiot light or the connection to the inlet line of the oil filter. And very important, check for any gas leaks that you may have, either from the filter, any of the connections, the fuel pump, etc. Inlet lines, the entire gas line, that sort of thing. As you can see here, this Maestro massaged engine has no oil leaks or gas leaks except for the one that we fixed. But it's got no oil leaks whatsoever. We checked underneath it, checked the pushrod tubes, checked the valve covers, checked the oil pump down below, check, 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 check. And I think you agree it runs pretty good so far, but the proof of the pudding is in the eating. We'll find out when we put it in the car how well it really does do, but it seems like it does all right so far. We've put the decals, a valve adjust decal and the oil filter decal on. These are the water soluble type. They're the only kind you can get anymore. I don't like them, but they're the only game in town. It's best also to wet the surface of the oil filter can before you put on the filter decal. You have to put these decals in water for about 2 or 3 minutes and they come right off. In fact, they usually come right off afterwards anyhow because they're pretty Mickey Mouse, but they do look nice. It's a finishing touch for your engine, so do put them on. We will eventually hook up return springs to the throttle here, and these are actually Solex return springs for Solex 40 PII carburetors. Stoddard Imported Cars has a good supply of these now. They got them back in stock again. This is September of 1986. I drill a hole through the linkage arm and then put the return spring through the drilled hole. You can do it either from the front side here or the back side like this, and attach it to the air filter base. Now the air filter will go on top of the carburetor, and these velocity stacks will go on the inside of the air filter, and you can usually make a little notch on the air filter base and attach the spring there. I use 2 springs, of course, one on either side, one on each carburetor, and that way you have double redundancy, which the Russians would have liked to have at Chernobyl, but didn't. Okay, that's pretty much it for the engine here. Let me turn the engine stand around. You can see the way we have the fire-up rig rigged up. It's actually very simple. This is part of a Volkswagen or Porsche, you can use either one. Transmission, cut to fit so it also mates onto the engine and the engine stand head still fits. Use an old dilapidated 6-volt starter with a 12-volt battery. That helps to turn things over really fast. Now, I use a starter switch you can buy at most any store really cheaply. And that way you can just click it on, hit the button, and that will of course fire the engine up. I'm pretty much done now. We can disconnect all the clamps and everything. We disconnect the battery cables of course before. But that's the rig job. You don't have to fire this up on the stand. Of course, it's a lot safer to put the engine on the ground. This being a very heavy-duty stand, a factory engine head and factory attachment for the head to the stand. This stand is built out of a recirculation line piping support for my GE boiling water reactor from one that was canceled. It's 3-inch square channel tubing, about 1/4 inch thick. Real herky stuff. Works just great. That's it. I pretty much have got the engine completely redone. We'll put a clamp on the inlet line. In fact, we'll really cut this off and put a hose there before we put it in the car. If you have any questions or comments on this videotape, we'd sure appreciate hearing about them. If there's some other phase of engine operations you'd like to see, engine overhaul, whatever, Super 90 stuff, something of that nature maybe, we'd be happy to accommodate it. Be sure to tighten down all the nuts on the linkage and grease all the linkage balls with either Bosch distributor grease or high temperature wheel bearing grease. I haven't done that yet. We just wanted to fire it up to show you this. We'll pop these off and grease them before we put the engine in the car. The rear plate is fairly easily assembled. It's not too hard to do. You got to put the rubber in it, and the front plate likewise. But for the time being, I think that pretty much shows you how you can do a Porsche engine in pretty good detail. And if you note the difference between this and when we first started it, it looks a little better now, I'd say. So send your comments or anything you'd like to understand here, or any comments on the tape that you'd like to express. Send them to HCP Research, 20655 Sunrise Drive in Cupertino, California, 95014. We'll be happy to listen to you and maybe even make improvements to this. We always like to improve the breed. That's why we do these things in the first place. We thank you for your support. Since there's still a little tape left, we'd like you to get your money's worth. So we're going to put a few more little items here at the end. Here's the crankshaft, the original crankshaft from this engine. We've taken the gears off the nose of the crankshaft at the machine shop. That you should have them do, not you. You can mess the gears up with a 2-jaw puller. It's better to have the machine shop do it. And now we're going to show you the magnafluxing operation. The crankshaft is first magnetized by placing running 600 amps or so through it in the magnaflux machine. Then liquid containing the magnetic particles is then poured on the crankshaft, like so. And the ultraviolet light is then shown on the crank. Magnetic particles will align themselves around either side of a crack and form a very nice outline of the crack when illuminated by the ultraviolet light. If we get the light at the right angle here, we can see this crank has a crack that goes almost all the way through it. There it is there. Let me hold it right there. As you can see, it goes around the journal inner radius and then through the widest, thickest part of the flange. And that's the way most cracks do occur. They go through the widest, thickest part of the flange. They always start at the journal radius. This particular one started on where the rod bearing had spun previously. Net effect being this crank is garbage. In fact, if the Maestro had attempted to drive this car across the country like he originally intended, he would have probably gotten in the middle of Nebraska when the crank would have went. If you leave the particles on and the crank magnetized, you can actually see the crack in the crankshaft with your eye in regular light, and there it is there. Not a nice thing to see. It means your crankshaft is worthless. It becomes a nice doorstop or boat anchor or something, but that's about all it's good for at this point. We replaced the crank with another one we had. This was caused by improper grinding. The grinding radius that was put into the crankshaft is that on the edge of the wheel when the crankshaft is ground on Porsche cranks. We measured this radius, found it to be 1/3 of the standard radius that Porsche puts on the cranks. Most likely there wasn't any radius on the wheel when the guy grounded before, and what radius was there was just found by wear, formed by wear of the wheel as it hit the side of the crankshaft. This will lead to failure rather quickly in less than 6,000 miles in most cases. And that's what happened in this case. This crankshaft was on its way to failure. We have data that shows if a crack is in the crankshaft, it will fail under normal usage in less than 6,000 miles. So I'd say this crank didn't have too many miles on it since the last overhaul, quote, overhaul, unquote. Nice boat anchor here we have. Assuming your crankshaft passes the Magnaflux test, the next step is to put it in V-blocks like here and check the runout or total indicated runout of the crankshaft by putting a dial indicator on the middle main bearing and spinning the crankshaft and seeing how far out it is. We'll show you how that's done here. Placed in the V-block holder, the dial indicator is put on the middle main bearing of the crankshaft. And you see it's a special dial indicator. It's big like that, spherical in shape, so it does not fall in the oil holes. And the crankshaft is rotated, and you can read the total indicated runout of the crankshaft on the dial indicator. Let me show you a close-up of the gauge here. The crankshaft is then turned through a couple of turns, and the dial indicator can then be read. This is a main bearing. It looks like it's turning, but it's not really. The crankshaft is held in the main bearing V-blocks, or held in the V-blocks on the main bearings. And you turn the crank over and read the dial indicator. I'll give you a shot of that here. Okay, here we actually are doing it now. And you can see that this crankshaft will have a total indicator runout of about 2,000ths of an inch, down to 0 there, then up to about 2 thousandths. It's an amazing gauge here. You can read 1/10,000th of an inch with no trouble whatsoever. Usual crankshafts have about 2 thousandths run out anyhow. You really like to see them down less than 1,000th. When you grind it, you can actually get the TIR down to about 0.1, a tenth of a thou or so. Our main bearing 2 is still in the V-blocks, simply by placing the dial indicator on it in the V-blocks, and check out the total indicated runout of the number 4 main, which very few people do, but which is very, very necessary to do. And here, as we turn it over, you can see that we'll also have approximately 2 thousandths of an inch of runout here as we turn this thing over in just a second here. There we go. From 5, 6, 7. So that's 2 thousandths of an inch total indicated runout on the number 4 main bearing. We'll show you a quick setup here of the crank grinder of how cranks are ground in a second. Now here's the crankshaft and the crank grinder. As you can see, it's held pretty securely in quite a machine. The crank grinder is one of the most impressive machines in a machine shop. And what we're going to be doing here is indicating off of the gear area of the crankshaft, where the gears go on. That's unground by previous grinders, so it's probably very good shape, and we'll zero that off. So 1, the gears on the crankshaft run true, concentric that is, and not describing an oval. And 2, that way you can use that point to indicate everything else off of and get all the bearings in line and get the plane of the rods and the plane of the crankshaft main bearings parallel to each other, which is what you want. And how it's done is the same way, by putting a dial indicator on the gear area of the crankshaft and indicating off of it, getting the crank centered such that everything else then can be taken from that center. It works fairly well. As long as you have the proper equipment. These crank grinders now cost something on the order of $50,000 or more. Even used ones are about $20,000 or more. They're not the piece of equipment you would have in your normal backyard machine shop, but in fairly good machine shops in the Bay Area, there are a few. And there are a few people. Bring the radius of the crankshaft journal with a radius gauge. That's the way to do it. They have machinist gauges to measure radii on the cranks. We find that it had 1/3 the normal radius of a Porsche crankshaft, meaning the previous grinder had done a butcher job on it. Okay, here's our crankshaft on the grinder. With the grinder in operation, about 2,000 indicated runout on the middle main bearing. We're going to be grinding the middle main bearing so we can actually see 2 things. 1, how the runout goes towards 0, and 2, how the size also drops as the grinder is actually grinding it. This way you can get a real-time indicator of what size your crankshaft is. Now the one that's not spinning, rotating around an axis is the one we're grinding. It's a middle main there. You see the wheel coming in, and pretty soon the wheel will touch it, and you'll see a few sparks fly from the bottom of the journal. There we go, now we're doing it. It's quite an impressive demonstration, though not quite as impressive as flywheel grinding. But still pretty impressive considering the size of the machine and the magnitude of things. Get it in focus here, cameraman. There we go. That other device supporting the middle main is called a steady rest. That's used to support crankshafts during grinding operations in some cases. And here if we take a look, we see the total indicator runout has dropped down to just about 2 or 3/10 of a thousandth. Those gauge numbers there, 2 and 3, are thousandths of an inch. As you can see, we're down to about 0.2 thousandths or 2/10 of a thousandth of an inch indicator runout, which means that the crankshaft grinding operation not only brings the crank down in size to where the second undersize or first undersize is correct, as you can see here, it's actually dropping in size as the crank is grinding, but also brings the total indicator runout down to next to nothing, well within specs, and makes for a very nice crankshaft. So when ground correctly, a Porsche crankshaft can be a very nice device. Will last 100,000 miles, no problem if the proper radius is put on it. But by the same token, if not ground correctly, or with the wrong radius, the crank can be destined for a very short life. In fact, very short life, like less than 6. How the connecting rods are ground on a crankshaft grinder. Here's how that's done. As you can see, the crankshaft grinder head is rotating about a circle, and that pivots about with the center of that circle being the center of the rod bearing journal. And that's how the rod bearings are ground. Think about that for a little bit, it'll become clear. It's quite impressive seeing a crankshaft grinder grinding the connecting rods with this big mass of both heads spinning around, turning the crankshaft, and the wheel inside there doing the grinding. It's a very impressive operation, grinding a crank, and it should be seen by people just to visualize what's going on, understand what's really involved. Once your crankshaft has been ground, it should be micro-polished. This is how that's done. It gets an idea of scale. There's the crank. There's the man who's going to polish it. And that big belt you saw, and that giant, what looked like a C-clamp, is the device used to polish it. The belt's brought down onto the main bearings. Main bearings are polished, micro-polished in this manner. Gets everything nice and smooth, gets out any defects in the crankshaft from, if you're polishing just a crank that has not been ground, it can remove some scratches. If you're polishing a crankshaft that has been ground, it gets out any machining burrs, etc. Makes the crank very, very smooth and gives both the crank and the bearings a nice long life. We even do the number 4 main, of course, too, so all 4 main bearings are polished here on the crank polishing machine. And then the belt is changed to a narrower belt to do the connecting rods. He's changing the belt to put another thinner belt on to do the connecting rod journals. And you see the crank is spinning at the same time that the belt is turning. The combination does the balancing. It's almost like an oil well drilling operation here, as you can see from some of the movement of the crank and the polishing device. That works very nicely, does the job. The journals come out sparkling afterwards. Your camshaft happens to look like this, with pits on the top of the lobes. This is a fairly bad example, or one that's pretty badly pitted. Even if it has a few pits, it's a good idea to grind it. Here's a better shot of the pits with a little bit of light on the subject. Very few people can grind Porsche camshafts. We can, so if you do need your Porsche camshaft ground, send it to HCP Research and we'll be happy to grind it for you. Show you here another cam that's a little more typical of the genre. With camshaft is much more typical of the usual cam you'll find in either a Super SC 912 or Super 90. You can see some of the pits there. As we rotate it around here a bit. That cam should still be ground. Note that's a 102 or a Super cam. If it has a 15 on the gear end, it's a C. If it has a 16, it's a 912. Normally the exhaust rockers or exhaust cam lobes do not pit as much as the intakes do because the rocker ratio is higher. If the cam is pitted, you'll need a cam grinder like this one to grind it, make it right again. Here Dima Elgin is setting up his cam grinder, getting the masters all set up and getting everything organized. There's a cam we're going to be grinding, show an example of how cam grinding actually occurs. It's similar to crank grinding, only different. You need another $20,000 machine for this purpose, and we'll show you how that's done in a second here. Okay, here the cam is actually being ground on the cam grinder. You can see that just from the sparks there on the wheel, The top of the lobe is being ground now. Eventually the entire lobe will form continuous sparks, indicating the entire assembly is being ground properly. The wheel's touching everywhere. You can see from the black area that's turning into a shiny silver area that in fact the cam lobe is being ground correctly. Now the master determines what type of cam grind is placed on the cam. We have masters for all kinds of applications, but we have one we really like called the Maestro Master Grind for street use. As you can see here, we'll give you a few examples here as the tape runs out of how this is cam lobe is ground. First at this